Welcome. We're really excited to introduce the animation rigging package for Unity 2019.1. I'm Dave Hunt. I'm a technical artist working out of Unity Copenhagen.
I'm Jean-Sébastien Campagna. I'm a technical animator working in Unity Montreal.
Hi, Olivier, an animation R&D engineer based in Montreal.
And the microphone back up. So I'm really excited to present these new tools here. I spent a lot of time in my career working in big games. For about 12 years, I was the rigging lead at Bungie, and it was an awesome experience. You know, big team, like 750 people, really high-end stuff. But I'll tell you, one of the things that's also been very interesting to me my whole life really is just doing it all myself. I mean, that's the dream, right? How far can you get on your own? And I'm really excited because what we have here really brings that one step closer. And animation and rigging especially has always been one of the parts that takes a lot of time to specialize in, and very happy to bring it closer to everyone here, because you can do this without programming, and if you know programming, you can take it farther, but it's all available to you right here. So the animation rigging package is now available. It can be easily installed through the package manager. There are links included here to our documentation and some samples to help you get up and running. This is our first release in Unity 2019.1, which will be released in just a few days or weeks, but the beta is already available right now, and we're already at work on the next version for 2019.2, where we're introducing keyframing. So if you want to play with that, it's also available through the public alpha. So just a brief note what we mean about preview. Please be aware things will change as we upgrade to new versions. But the really exciting part is that means you get to be involved in our development process, and we get to make sure that it includes what you need. So please stay in touch with us. Why we're doing this right now is to really involve the community, and we really look forward to hearing from you. Here's a link to our forums. We'll also include that link at the end of the presentation. So please let us know how it goes. So here's a brief overview of what these tools enable you to do. First, you need to start with a character that has a skeleton and skin weights, and some animations. We don't yet have rigging tools for this part. We eventually intend to, but what you can do right now is from there you can set up constraints to define procedural motion relationships on your skeleton at runtime. This is what is known as runtime rigging. You can do really useful things during gameplay. For example, world interactions. You know, hands interacting with props, feet interacting with the ground. If you want to aim at something dynamically. To start off, we need to set up rig builder on the character's animator root. And next we can set up rigs. These rigs go on child game objects, and then we add them to the rig layers list. From there, we can add rig constraints. These are the basic building blocks that can be assembled into very specialized setups. They're very modular, and you can get creative with how you combine these into more advanced and specialized rigs. And these things can help your games at runtime. Here's what it looks like when it's all set up in your scene. Notice that the constraints are added to child game objects of the rig. This is how the rig knows that a constraint is associated with it. And this is because we're using the scene hierarchy to determine the order of evaluation. And that makes it very easy from an artist's point of view to influence this and change the order and get exactly the behavior that you want. You can even change how this works at runtime. And for working with the rig, we need to see and interact with the skeleton. So for this, we have the bone renderer. This lets you add transforms to a list, and now you can interact with them in scene view, and you don't have to dig through the hierarchy anymore. You can just select it right there, and you can visualize it in a couple different ways. Here's a couple different display styles that we're offering. One thing I like to do is set up multiple bone renderers on my character. So here I have the body on one and the fingers on a different layer, because I don't always want to see all that detail, and I can hide and show it when I want to. The twist bones are on yet another layer. So if I'm a rigging person going and working on that, I might show it and change the local rotation axes, change the size, and get it very precise look and feel. But if I'm not working on rigging, I'm animating, then I will just turn it off and hide that. Here's how to set up rigs on your character. So first we need to add the rig builder component onto the animator root. And this is the top level game object that has the animator component. Next we can add child game objects. And this is where we add rig components. And these get added to the rig layers list. Notice the rig has a weight value. There it is on the rig builder list, and that is considered a valid rig. It doesn't do anything yet, but it's set up correctly. And you can add as many of these rigs as you want. This is really useful for creating specialized behavior. Like here I have a sword rig, which we'll go into more detail. You can turn it on and off with your gameplay code, and it's only active when you need it. And this is the really cool part. Each rig has its own weight value. So you can blend these in and out very smoothly, and they will all just evaluate in the same order of execution that you've defined. This is where I'm really excited to see how people use this and what kind of creative combinations you can come up with. It's pretty open-ended. Now here's a list of rig constraints that we are offering with the package. These are very modular and general purpose. They're open to be combined in many different ways. So it's really useful if you're setting up things like world interactions with your character. So instead of making a whole bunch of different individual animations, you can have a relatively small set of animations and then dynamically change them at runtime to get a lot more variety in behavior. You can also get better deformations on skin mesh characters by setting up skeletal deformation fix-up. Things like twist bones to help preserve volume on skin mesh characters. Make it look much closer to how real anatomy works. And it's very fun to add these physics-based constraints to characters. And you can get dynamic secondary motion much more efficiently than the fully fledged rigid body physics system, because this is more optimized and actually works great on character rigs. Here's how to set up rig constraints. First, we need to add a child game object below the rig. Then we can add a two-bone IK constraint. Next, we're going to set up the bones and effectors. And when we press play, we can see the constraint evaluate at runtime. And the best way to get started with learning how these constraints work is by checking out the samples included with the package. Inside of Package Manager, there's a button to just import these directly into your scenes. And there's a scene for each project, for each constraint that demonstrates how it works. These are made by our technical animator QA lead, Yanghai, and I love these. When I was learning the package, I honestly just went straight here. I didn't even need to look at documentation. It's really easy to inspect and see exactly how they work. Here's what they look like. The sample scene for the blend constraint. Very straightforward. This is how you can blend the position and rotation between two different transforms. Each one has their own weight value. And I've already showed the two-bone IK constraint. We have a different kind of AK solver as well. This is the chain constraint, chain IK. It's useful for longer bone chains like this tail of a scorpion. And there are many different kinds of IK solvers that could be built, and we know that each game production has specific needs. So we intentionally built the animation rigging package to be easily extended in C#. So you can build your own constraints. In just a few minutes, we'll get to hear from Olivier, who will show you how to write a custom constraint. And this way you can build whatever type of IK solver you might need. So this automatically makes it work efficiently with the animation stream, and you get multi-threading automatically through the job system. Here's an example of physics-based constraint. This is the damp transform. This allows you to add smooth procedural motion to your constrained object and independently control both position and rotation. This kind of physics is separate from the main rigid body physics, has a lower overhead at runtime. It allows you to have a lot more of these on your characters at runtime. It won't hurt your frame rate. So runtime rigging happens during gameplay. So in order for me to learn how this works and try it out, I had to make a simple game of my own. I implemented these basic player controls and used the animation rigging system to get some very cool mechanics. I'm a big fan of the Metroidvania genre, so I went ahead and did a mashup of some of my favorite games, and some games like Strider 2014, Shadow Complex, and over a couple weeks, I just put together this really simple gameplay. I'm really happy with how it turned out, and the runtime rigging made it possible to do things that you couldn't do before in Unity very, very easily. And with a very small set of animations, I was able to get pretty varied gameplay. So here's how it looked like. It's a ninja game, so we need to have very fast and responsive player control. At any time, no matter what he's doing, Ninja always needs to be able to attack with his sword, throw shuriken, and these are animation layers that will replace on top of any animation that's playing. And yes, he can use a plasma rifle, because a ninja should be able to use any kind of weapon he finds. And the environment here is made using the megacity, which you may recognize from Unite LA last October, and it was also re-mentioned in the keynote yesterday. And I don't know if it was said clearly enough, but this entire amazing set of art content is being released for free for people to use and learn as an example of the DOT system. That's the data-oriented technology stack. So please check out Mike Acton's presentation on Wednesday at 3:30 in West Hall, room 2020, if you would like to learn more about this. So let's take a look at each of these features and see how I made them using runtime rigs. First, I set up a deform rig, and this is where I've added twist correction to fix up deformation on his arms and legs. So you can see it pop to a broken-looking position when it's turned off. The twist correction helps us counter-rotate this shoulder bone to make it look more realistic like actual anatomy, like flesh and the clothing. It's really easy to set this up, and even basic characters will look much better this way. Here's how I implemented the shuriken. The ninja needs to be able to throw shuriken throwing knives in any vertical direction 360 degrees. So to set this up, first I used some new virtual bones. Virtual bones are just new game object transforms that can be saved with the prefab and animated just like other bones. Next, I added a 2-bone IK constraint to control the left arm. I set the virtual bones as the IK targets, and I animated them in a new clip where he throws the knife. And I have an animation event that gets fired right when the projectile needs to be spawned. This animation clip is set up as a replacement layer in the animator state machine. And I have another virtual bone, which I'm using to control the vertical aim. I'm using a blend tree here to go between a straight up pose, a forward pose, and down pose. And since the IK targets are child of this, they'll follow. When that thing rotates up and down, he'll aim. This way I can throw shuriken in any different direction. I only had to make one simple animation for the IK targets. Shuriken. So, next I built on top of this same rig to add the katana. I wanted it to work the same way, where you can aim up and down, because it would be kind of stupid if he has an enemy right below and he can't strike it. I hate that when it happens in games. So let's fix that. The vertical aim works exactly like the shuriken, and since I added the same kind of a 2-bone IK for the right arm, I get that vertical aiming for free. Although swords bring a new factor, which is the horizontal aiming. If you have ever tried making a sword animation, you know it can be very hard to create a smooth arc. Even if you have the poses perfect, sometimes the subframe interpolation is wonky due to like gimbal lock and Euler angles. So, the best way to solve this is with an aim constraint. I have a remote target that the sword will always aim at, and as a parent of that, I just rotated this in the animation clip. It gives a perfectly smooth animation arc. This is especially visible when you have a sword trail with either particles here or some kind of effect. Here's another example of how I used the runtime rig constraints to make a follower character. And this was inspired by Alucard, his dark magic abilities from Castlevania Symphony of the Night. I think it must get lonely running around this megacity, so he needs a friend. And this can give him some power-ups or special attacks. Maybe it will resurrect him like in The Messenger. Awesome game, by the way, also made with Unity. I'm using the damp transform constraints, very simple. The butterfly follows this transform that's in the ninja's skeleton. So wherever it goes, it will smoothly follow and catch up. I didn't even have to keyframe anything. And I added a spotlight, so it can at least do something, and that aims at a target in front of the character. So I'm thinking that this is some kind of a special ultraviolet light that only the ninja can see, otherwise it would give away his position, and that's not very ninja-like. Anyway, you can dream up whatever cool gameplay mechanics you like, and the runtime constraints will make it easy to implement. Here's a final example made by Yang Hai, who I mentioned before, who made the sample scenes. And I didn't have time to get up and running in the mega city with the HD render pipeline. It's going to look sweet when I did that, which we will follow up later. We're going to do a blog post about this guy and show exactly how it's made as an example. But this is a really good example to show that these constraints work on any type of skeleton. This is not just human. And he has set up some really nice procedural motion here that is entirely made with constraints and player input. And there's no keyframe animation at all. And he's getting some really nice physical looking motion using the damp transform. It has this nice momentum and weight, like a big heavy object like that would really have. And with all of this complex mechanical functionality, we're getting it to behave correctly because everything I can control the order of execution very exactly. For example, the IK system needs to execute first, and then as a final step, this hydraulic piston is always going to stay correctly connected to the end. Next, I would like to hand it over to my good friend, Jean-Sébastien. He is a technical animator who has done a lot of work in the AAA game industry. And he made some really awesome setups using the same basic content, Ninja and the Megacity, but he made more of what he's used to making as more of an action third-person shooter. So, and he has the pleasure of working directly with the animation team in Montreal. So here he is, taking on the next step.
Hi, everybody. Thank you for coming. Thank you, Dave. So this is a little video showing what I worked on the last few weeks. So my role in Unity Montreal is basically an embedded technical animator in the team. So I work with the developer to actually develop use case and see if we can push the tech to address all the issues that we saw in game development. Most of my experience are in AAA, like Dave said, and mainly with first-person shooters. So over and over, these years of production, I saw always the same kind of issue. One of these was actually the ability to connect the character and the weapon. This has always been an issue in games I've worked in. The other issue we had is the ability to streamline your animation library, so you want to reuse most of your clip as much as possible. And in this case, the animation rigging package is a very decent solution for that. Also, one of the things that was really sad is to see all those hours of polishing animation just go down the drain when you apply the animation compression in the engine. So that was hard to see all the time. And finally, also, sometimes as an animator, you can feel like you're just an integrator. You just take that file, that FBX file, you put it into the engine, and you have no more control on top of it. So again, was very sad. But I feel like with the new animation rigging package, we have much more control as an animator on the final look of the animation. And honestly, it feels very empowering. I'm super excited of what's come next. So the first thing we need to do is actually define 2 use cases. We had many, but we pick only 2. So the first one was to see how we can have the weapon interact with your character. And the second one was to actually repurpose the animation or state machine for different weapon type. So I think here Dave did a wonderful job to explain how the rig layers and the rig component works together. I just want to point out here that this is how I've used it. I use a single animation weapon, and I just layer on top with the rigs different hand grips and different weapon type. So actually it works really well and super stable too. So at the beginning we had to deal with the player attachment, so I'm going to dig in a little bit into it and explain how I've achieved that. So I've used Motion Builder to build a set of machine gun animation, and when I say a set of animation, it was only with machine gun. I had no pistol animation in my animation set. I used a mechanism state machine to organize them together, and then I create a pair of multi-parent constraints for each weapon. I use the weight parameter to actually manage the constraint activation of each constraint. So in this case, if I take the pistol bone in example, I can activate the pistol mode constraint here to have the pistol bone aligned to the weapon bone. Otherwise, if I use the pistol holster, the pistol will align itself to the pistol holster position. So again, it works super well, just as I imagined it, and I was really happy with the result. So our first use case was actually to connect weapon and character. So we'll see how we achieve that. Here's an example of the machine gun rigs, a constraint stack evaluation. It's a basic schematic view. So the first thing we had is an animation source. Animation source can be state machine, a timeline, or basic code input, any sorts of animation clip. We use the override transform constraint to take over the weapon and control it. And then we use the multi-referential constraint here to actually get more level of control on top of the machine gun object. We use multi-parent constraint to attach both IK effector to the weapon, and we finally solve both arm with the 2-bone IK. So if we dig a little bit deeper into it, the override transform, it's actually super powerful. It's one of my favorite constraints in the animation package because it allows you to actually set a source object and use the pivot mode. And what it does exactly, it's hijacking the animation source, and it combines it with the source object transform, give you a new result that you can output back into the animation source. So here's another slide more on the schematic to explain it. So it's basically the best comparison I can come up with this is an animation layer, an additive animation layer. So super intuitive, much more control on your final animation, and super easy to repose your character or your weapon in this case. And the beauty of it is it's all happening in runtime, so a lot of more control for the animator at the end. Then to control the object, we had the multi-referential constraint. So I think there's a story worth telling here. I was trying to build myself some kind of multi-pivot rig, and I was using multiple parent constraints to do that. And I was going to the pain of just activating or deactivating all the weights. I have like 4 of these. And then Olivier came by my desk and he said, hey man, I think I have an idea to solve that issue. Just give me a couple of days. And the very next day he came back. He had that new constraint, which is called a multi-reference constraint. And it was super useful. It actually allowed you to set a driver object over a top of multiple reference object, and the driver object used like a temporal parent over these objects. And you can switch between these reference objects to set them as the driver. So this is super powerful. I think there's a lot of potential there, mainly for keyframing or authoring. But I'm glad that it made the final cut to the animation package because honestly, I can't wait to see you guys use it because I know you're going to come up with great stuff. So again, a schematic view of how it works, a little bit more. One thing is important to mention here is when you switch between the driver, it preserves all the offset between all the reference objects. So basically, your pivots are not touched. They're staying where they are. They're staying relative to each other's. All the offsets are cached and preserved. And you can basically switch from any driver object anytime or anywhere in your animation. It works just super well. Next, we had to attach the IK effector to the weapon. So in this case, I've decided to use a single multi-source parent constraint with 2 source objects, actually. And what I did is I was actually switching between the 2 different end grip. To do this, I just play with the source weight of each IK target. So I activate or deactivate them in order to get the result. So you can see that the end is sliding to a position and to another one, and the IK is preserved simply like that. Here's again a more schematic view of it. Super simple solution for multiple weapon and different set of hand grips again. It simplifies a lot the rig setup due to the fact that you just only need one single parent-child constraint. Also for the hand grip, I've been able to use multiple override transform and apply them on the hierarchy of the fingers. So each of the finger contain their own override transform. I use local mode and just preset some value that I store into the constraint and apply it as a pose basically on the fingers. I use a rig weight parameter to blend between original pose and target pose. So super useful, super intuitive. I really enjoy using it. And finally, I use the 2-bone IK to solve both arm connection to the weapon. Actually, I don't know if you saw yesterday the keynote. They were talking about Call of Duty. And I think the team who did the game actually came with a similar solution. So I'm quite happy that we have something now coming out that will allow everybody to mimic that solution. Also, I think it's important to mention that when I was working at Ubisoft Montreal, the last game I did was Rainbow Six Siege, and we had like a ton of weapon and ton of different hand grip. And that's actually the solution that we came up at the end. We just create high-K constraint that allow us to align the hand to the weapon. So we had different hand grip. We can match every weapon and stuff like that. The thing that we didn't have actually was hard-coded in the engine, and the animator or the tech animator didn't have access to any of this. So it's why here I think it's super powerful because everybody can use it. You can set up your own combination of constraint, and it works super well, super intuitive. I was very happy with this result. So on our second use case, I wanted to see if we can repurpose the animation source, in this case our state machine. So what I did first is I've used a multi-parent constraint again to constrain the pistol bone to the weapon bone, but in this case I've used the maintain offset position and rotation option. So I was able to actually keep the existing offset between both objects instead of aligning them each other on top of each other's. So that was, again, super useful, predictable, results were great, and simple to use. This is a schematic view of the constraint stack evaluation of the pistol rig. As you can see, it looks a lot like the machine gun, minus the multi-referential and multi-pivot rig. I didn't put that in because I didn't feel I needed that type of control on a pistol. So just to show you that it's pretty manageable. You can build what you want and reuse it, or actually strip some part of it, and it's really modular. Finally, when we apply the pose of the pistol on the machine gun animation, we had a shoulder offset here that you can see on the shoulder or clavicle. And what I did is I actually use another override transform, again using pivot mode, and I just apply a rotation offset here on top of it. And since I'm in pivot mode, it's just, post-process the animation with the offset after that. And it worked beautiful. It's, I've been quite happy with the result. And I think if there's a conclusion to take out of this for animator, is I feel that this animation rigging package gives us a lot of control over the final look of the animation. It's really powerful, and it gives us a way to express ourselves at the end of the loop and give you more control on the final animation look. So I'm super excited. So now I'm going to hand it over to Olivier, my friend and co-workers, who was the main developer on the animation rigging package. Thank you.
So thanks, Jean-Seb. So far, what we've seen in this presentation is clever usage of constraint shipping with animation, or the animation rigging package, to solve some specific use cases. But from the very beginning, we wanted to create an open rigging toolkit, since there are multiple reasons why you'd want to develop custom constraints. And for one, I know I'm preaching to the choir here, but each production has distinct needs that general packages cannot always fulfill. A handcrafted constraint can be laser focused to solving your specific use case, which in turn has a tendency to increase general performance, while also possibly creating off the beaten track interactions and behaviors. To ease the learning curve of developing your own constraint, all the source code of the rigging package is freely available as a reference or yours to make your own. And if you're happy with the end result of what you built, you could always share it via Unity's asset store or GitHub. So let's take a step back and look at the animation rigging package from a developer's point of view. It's currently built on top of C# animation jobs using the Playables API. Unfortunately, we won't have time to go through the details of this tech, but it's worth reading the following blog post as an entry point. And briefly, C# animation jobs enable you to modify an animation pose on the animator thread prior to writing it back to the game objects. And since the animator takes care of scheduling the work per character, it makes it easy to write safe multi-threaded code. Otherwise, the package itself takes care of scheduling the work. Otherwise, the package itself abstracts all the complexity of creating a rig and associated constraint graph that needs to be appended to an animation source. It also makes it possible to interactively layer rig hierarchies, as you've seen with Dave and Jean-Seb, and build interesting constraint combinations overall. And it's intuitive to understand, since scheduling a rig constraint is basically defined by the order in which you declare it via the hierarchy view. So let's take a look at what's involved to augment the rigging package with your own constraint. It basically boils down to declaring a rig constraint which needs three things: an I-weighted animation job that will implement the constraint algorithm, a I animation job data that will contain all the necessary data that the job needs in order to do its work, and a animation job binder to take care of creating and destroying the specific job given its data. As a simple example, let's create a hello world constraint that basically reads the position of a source object and mirrors these values to a constrained object. So if all the parts were already implemented, the declaration of this constraint would look something like this. Let's take a bit of time to dive into each specific part of our hello world constraint. The hello world job is an I-weighted animation job. And as you can see, it's nothing more than an I animation job containing an extra weight property that is actually auto-populated for you. You only need to make sure your algorithm uses it in order to blend in and out the constraint influence it will have. Here's what the hello world job code looks like. So using the constrained and source object handles, we apply the negated position of the source to the constrained object and use the job weight value to linearly interpolate the final result. And just like any other Unity job, we can further optimize its execution using Burst. The hello world data is an iAnimation job data which requires us to declare two functions. IsValid to check that the data needed to create the job is correctly set, and setDefaultValues, which initializes the data when we first create the constraint. Here's how we would implement hello world data. It naturally contains transform references to both the constrained and source objects. Now let's write the hello world binder, which declares an animation job binder. We need to provide the implementation to create and destroy a job. At this point, this is what the hello world binder looks like in our case. In our create implementation, we simply return a new hello world job with both constraint and source handles properly bound given the past hello world data. Our destroy function does not need to dispose of anything from the job since it does not hold any sort of native collections. Now, this is the final result after declaring the hello world rig constraint. We have a component we can add under a rig hierarchy that will give us a very simple mirror position constraint. And just to reiterate on this, the constraint execution itself does not happen on mono-behavior callbacks, but inside a job. This means that all these rig constraint components are exclusively data holders used to serialize settings and properties. With our package, you can fully concentrate on just the implementation of your constraint behavior without thinking of how you need to hook it up for evaluation. Plus, since this all lives in C#, everything you write is hot reloadable at editor runtime, making for a tight iteration loop. So let's have fun with this. Let's move on to another more dynamic setup to see how we can build a custom jiggle chain constraint. This could be useful in many different situations where you'd like to mimic, say, the animation of an eel, a fish, or snake. It could also be used to procedurally animate dangling accessories on your character, for example, a ponytail, or extra jiggle bones to simulate secondary fat motion on the skin. Here's an example as how you can build a jiggle chain given specified root and tip objects. But first off, let's reduce our problem space, considering that the simulation logic will be applied the same way throughout the elements of the chain. We can limit our explanation going forward to just computing the jiggle simulation on the tip object. Let's look at the chain hierarchy at rest configuration. From the position of the tip object, which we'll call target root, we'll extrude a target position given a dynamic offset and direction. We'll initialize a particle composed of a mass, position, and velocity at this extruded target location. Now that our constraint is properly initialized, let's look at the next frame when the animation stream displaces the root object. As you can observe, our target position was also affected, and we now need to solve for a new particle position given this current configuration. In our setup, we have forces generated from two types of constraints. First, we have a constraint that makes sure that our particle respects its initial dynamic offset distance from the target root, and another that further constrains the particle to move back to its new target position. And finally, to make things interesting, let's make sure that we also react to external forces such as wind and gravity. So now that we've gathered all forces acting on our particle, we can perform a simulation step to displace the particle to a new position. From this new position, we'll be able to compute a new aim vector from the target root. And using this vector, we can compute the delta rotation we need to apply to our object in order to respect the current configuration. So applying the same logic to the rest of the elements of the chain gives us the original wanted behavior. But now, what if you needed to support a jiggle, overshoot, and roll? The current constraint setup won't be able to simulate it since the particle lies on the same axes. To solve this without too much effort, though, you can create a second particle constrained to another orthogonal extruded target position that will conveniently give us the behavior. Dave kindly created some bones and skin weights on a few of the Book of the Dead assets in order for us to test our custom constraint. From it, we get rubber trees and jiggly fern leaves. This is my cue to drink. Thanks. And since we decided to add an input for external forces, we can hook up wind zones to our constraint for fun. But as you can imagine, that external force input could be used for many other things, if wanted. It doesn't have to be wind, it could be anything else. Jean-Seb also decided to take the constraint for a spin and applied it to the arms of the ninja, which gives some nice motion overlap with a sense of weight to his final locomotion. But depending on your constraint settings, it can easily go from subtle to completely ridiculous. So here's what the final constraint component looks like. Unfortunately, won't have time to go through each line of the jiggle constraint code. However, it's freely available for you to download via the link encoded in this QR code. You can use it as a reference implementation when you decide to eventually write your own using the animation rigging toolkit. And just an FYI, the QR code is also on the last slide, so if you want to take pictures then, you can. So to summarize, the animation rigging package is available since 19.1 and yours to explore right now. It greatly simplifies the rigging process of characters by removing a lot of the infrastructure work that needs to be built in order to hijack the animation stream. You can focus exclusively on the fun part, the constraint algorithm of your custom setups. And again, since it's all in C#, it's hot reloadable and easily shareable, which makes for a tight iteration loop between art and dev. If there's one takeaway to get from this presentation, it's the following. Please take part in our forum discussions to just shape and define this tech with us. We're super receptive to feedback and love getting more insight on your animation pipelines. And like Dave mentioned, we'll also make sure to do a follow-up blog post on this talk and share all presented assets as extra rigging examples. And lastly, stay tuned for more, since we have a lot of ideas we've been kicking around internally, and a few of these will make their way in the next version of this package. We'd like to take a bit of time to thank everyone that contributed to this tech and multiple demos part of this talk. We'll let this video roll while we move on to any questions you may have. Thank you for attending our presentation.
Let's see, do we have time for some questions? If so, please feel free to come up to the microphone.
Hello, can you hear me?
Yes.
My name is Danilo Moura. I have been fortunate to work with a lot of volumetric video projects inside of Unity. My biggest challenge right now is that if I want to make, in my volumetric video, what I mean is every 30 frames you have a new mesh, and you are playing that. It's like imagine an Alembic file with 30 meshes per second, or even 60 meshes per second. And if I want to interact, I want to put a bone on it and be able to do like a look at, so I can make, you know, my virtual avatar to be able to look at you. So I'm interested in suggesting to, you know, maybe exchange cards and try to figure it out and provide some of those assets to you guys and try to figure it out a way that I can actually, you know, control this. Because my biggest challenge right now is that if I skin, I'm going to be skinning for the first frame. And, you know, I want the bones to have that influence on the mesh.
And gotcha.
For 30 frames per second. So I would like
Okay,
to know your thoughts about that.
Sure. To repeat what I understand the question, and correct me if I'm wrong, he's working with point cache, Alembic cache, things like this, which is a per frame mesh playback. And are there ways to control this using bones? So what I will say is that Alembic caching is one of the compromises that's often done when you're coming from another package like DCC, where you can't get it all supported in engine. So one thing this does is actually removes the need to do Alembic cache for many cases, and you can actually just control it dynamically if you have a skeletal mesh character already. Another point worth mentioning is that I do want to mention that the high influence skin weights is released, so we now are no longer limited to 4 influences. You can have actually up to 255 bone influences. FBX is limited by 32. So what that means is, yet again, don't have to point cache, Alembic cache if you don't want to. But to also speak to the question, can you actually influence Alembic cache with this? That would require the ability to create skin weights on the fly, which is currently not offered within this toolkit. It's possible. In fact, we do it already in 2D. So there's already skeleton creation, skin weight creation tools in 2D using our sprite editor. So, I mean, if you find clever ways to do this, then absolutely you could use the rig constraints on the bones. And if you have some clever things you come up with, please stay in touch with us.
Okay, I will. Thank you.
Yeah.
Hi there. My name is David Wilson, and wondering if this is the kind of rigging setup that would be useful for offsetting feet for world context for dynamic nav meshes.
Yeah. So question was about, is this useful for correcting foot placement on the ground? Yes, absolutely. So there's multiple IK solutions supplied here, including 2-bone IK, which is most commonly what we use for something like a leg and a foot. Although there is the need to build the additional tooling of, ray casting or shape casting to the terrain, and then possibly modifying the height of the hips and knowing what part of the animation you actually want to activate this. So at my work at Bungie, I was part of 2 separate implementations of this. One of them was much more data-driven using keyframe events, and it worked. It was a bit laborious. Another one was totally procedural, like they analyze skeletal motion and know when the foot's supposed to be on the ground. I was skeptical at first, but I was surprised it worked really, really well. I mean, those things do take an extra level of tooling, which isn't developed yet. We're releasing the very base level of constraints right now, but it's absolutely the next steps. And so FootIK is a really important solution for games. It is something that's on our roadmap. But yeah, and once again, if the community develops really sweet versions of this, let us know how it goes, because there's many ways it can be done, and we want it to work for multiple productions.
All right, happy to discuss offline.
So moving to a larger scale, obviously there's some point at which you don't want to run your full rig on every single character in, say, a gigantic San Francisco-sized crowd. So is there any sort of tooling on the back end to like bake a typical case and basically, based on some priority parameter, basically only run the full rig on the most important of those characters?
I don't want to take all of them. Do you have one? All right. I have too much to say.
That's fine. So the question is in regards to LOD, basically. Yeah. So like shutting off rigs if they're too far away from the camera, so you don't have to do extra evaluations. So in the package itself right now, it's a kind of core set of tools, and the LOD system would have to be something that you would have to manage on top of this. I think eventually that's where we'd love to be, like have more sets of general high-level tools, like foot planting is, like the question that was asked before, is something that we'd love to just, give out eventually. So definitely like things like that, are worth bringing up on our forum discussion board. And we're definitely going to take notes because we want to help out in those situations for sure.
All right, thanks.
If I could add briefly.
Yeah.
So like, I'm a technical artist. I'm not the engineer that Olivier is, but that question to me sounds within range of something like tech art could handle. It's like basically, give me a distance, and if you're beyond that, switch to the other rig. And like the rigs, there's multiple rigs, there's weights. You can set, there's the high detail close up one, and there's the low detail far away one. It's in as many layers as you want. It should be pretty easy.
But you have to script that.
Oh yeah, this would be C# developed, but I kind of think it's in the like, at least a basic implementation of this shouldn't be too hard with C#.
I think we have time for one more.
Okay. Yeah. Are there any more questions or follow-ups?
You mentioned that animation keyframing is on your roadmap. Is there any limitation as far as which workflow we choose, as far as like humanoid or generic rigs, and how that translates to human pose and muscle clip?
So right now, it actually works on both. So you just get the animation stream and you set your constraint, and it's going to modify the animation stream. So it's going to work on a humanoid character as well.
Awesome.
Yeah. And in terms of keyframing, 19.2 actually kind of exposes some of that functionality. We're not totally there yet, but we can start doing pretty cool workflows in the animation window. So, yeah.
Thank you.
We'll be glad to hang around in the hallway for more questions if anyone else has.